All right, 1.8, combinations and composites. The first thing we're going to do is combinations. Okay, a combination function is when you either add, subtract, multiply, divide. However, adding is pretty easy. But when we have a difference, when we subtract, what would I suggest you do? I distribute the negative. All right? If you don't distribute the negative, you're going to make some mistakes. Okay, I promise you that. And then if you have a product, okay, if you have two binomials, what four-letter F word do I like? What are you going to do? You're going to FOIL it. That's right. All right? And then if you have a quotient, you put one on the numerator, one on the denominator, but what do you always need to be concerned about? You have domain restrictions. What are you always going to be concerned about? Like that. The denominator can't be 0. Okay? So you have to worry about those domains. So this first one I have is my function 2x plus 1. My g of x is x squared plus 2x minus 1. And so we're just going to add them together. So we're going to find f plus g of x, and then I'm going to evaluate at x equals 3. So if I have f plus g of x, I would just have 2x plus 1 plus x squared plus 2x minus 1. Again, this is just a sum, so I don't really have to worry about it. But if it were subtracting, if it were a difference, what would I probably do right now? I would distribute the negative. However, this is a sum, so I don't have to worry about it. So I just combine like terms. So when I combine like terms, let's do higher power first. Do I have any buddies for the x squared? No. Do I have any buddies for my x's? Sad day, I do. So what do I need to do? I get what? I get 4x. How about my constants? I got 1 and negative 1. Those come together to be what? 0. So now I have f plus g of x equals just x squared plus 4x. All right. And then I need to go to the second part. I need to evaluate at x equals 3. So then I do f plus g of 3. And I'm just going to substitute in 3 in for my values right here. Okay, in for my variable right there. So then I have 3 squared, which we call 9 plus 4 times 3, which we're going to call 12. I add them together and I end up with 21. All right, good. All right, so that's one way to Tampa. Okay, I already had f plus g of x, so all I did was substitute in 3. But I'm going to show you a different way. So f plus g of 3 is the same thing as saying f of 3 plus g of 3. And I'll show you this other way to Tampa. So if I substitute in 3, in for x, up in my top one. If I substitute in 3 here, what's f of 3? Say it louder, Cooper. 7 plus, what is g of 3? Now I'm going to substitute in 3 in for this. So that I have 3 squared, which is 9 plus 6 minus 1. So I end up with 14. So I'd have 7 plus 14, and that equals 21. Do you see how we went to 2 different ways to Tampa, but we still got there? All right. Now, all right, so this one, I have f of x is equal to x squared. G of x is equal to x minus 3. I need to find the product, f times g of x. And then I'm going to evaluate at x equals 4. So now I have f times g of x. So my f of x is x squared. My g of x is x minus 3. What do I need to do now? Distribute. So when I distribute, what am I left with? X cubed minus 3x squared. So now I have that as my combination function. All right. And so from there, I need to evaluate the product at x equals 4. So now I do f times g of 4. So I substitute in 4. So what is 4 cubed? 64. Minus, what is 4 squared? 16 times 3 is 48. So 64 minus 48. So 64 minus 48 is? Cade? Would you like to phone a friend?
16.
16. Good job. All right. Now I'm going to show you the other way to Tampa. So we could actually do f of 4 times g of 4. Okay? If we didn't already have this made up, this would probably be your better way to Tampa. So f of 4, if I substitute in 4 in for f, what do I get? I get 16. Times g of 4 is 1. So 16 times 1 is 16. All right, pretty nifty. That could be another way to check yourself if you want to. All right, so now we're going to find quotients. Okay, so I'm going to find quotients, but what do we always need to be concerned about with quotients? 0 in the denominator, and these are square roots. So this is a great review for us finding domains. All right, so I have f as square root x, and I have g as square root 4 minus x squared.
Hey, what are we doing today? 1.8.
So now I have f over g of x. So I got square root x on top, and then I have square root 4 minus x squared on the bottom. What can we not have on the bottom of a fraction?
0.
We can't have 0 on the bottom. Exactly. What else can't we have in a square root? I can't have a negative in a square root. So now I have a square root on the bottom, and I can't have 0 on the bottom. So what do I set 4 minus x squared? I don't want it to be 0, but it also has to be just greater than 0. Why do I not have this one as greater than or equal to 0? Because it can't be 0 on the bottom either. So I add x squared over, I square root it, I get plus or minus what? 2. So I'm in between negative 2 and 2, and I don't include them. Why don't I include them? Because it can't be what? 0. And this is the way to check yourself. Pick a number in between negative 2 and 2.
0.
1? 1 sounds great. If I substitute in 1 here, I got 4 minus 1 squared, which is what? 3. Is that okay? Yeah. But if I were to say something else outside of this interval, like 3 or negative 3 or something like that, if I were to substitute in 3, I'd get 4 minus what? Say 9. 9. So I get square root of a negative 5. Can that happen in a square root?
No.
No, not in real life anyway. All right, those are imaginary. All right, and we'll talk about those later on this year. So I have it in between negative 2 and 2 on my interval. However, I also have the top thing to worry about. So what do I need to set that radicand as? X is what? Greater than or equal to 0. So what is that one? What's my lowest number there? 0. Does it get to be included? Yes. So we use a what? A bracket. And it needs to go all the way to infinity. Now we need to combine these two parts of our domain. All right, so now I need to combine those. So what could be my lowest number it can be now?
1.
0. Because negative 2 is not actually on this interval yet. These have to be unionized. Okay? So I can't have negative 2 because if I substitute in negative 2 up top, I got square root of a negative 2. Is that allowed? No. Okay? And so I have to start at 0, and I can include it, and it goes to what? 2, and I don't include it. So here is the domain of f over g of x.
That's the final domain.
That's the final domain, exactly.
It's quite small.
It is small. Well, it's actually kind of large, too, if you think about it. You got infinite numbers in between them.
Yeah.
All right, so now we're going to do g over f of x. All right, so now I'm going to substitute in g. So I have 4 square root 4 minus x squared on top, and then over square root x. I'm still going to work with my denominator first. However, x can be what? Is it greater than or equal to 0? It's just greater than. Why is it just greater than? Because I can't have what on the bottom? I can't have 0 on the bottom. So what would that interval be? 0 to infinity. Do I get to include either one of them? No, so they're parentheses. All right, and then I set 4 minus x squared, what? Greater than or equal to. Why am I allowed to be equal to now? Because it's on the top. It's in the numerator. So then you add x squared over, you square root it, so it's still in between what? Negative 2 and 2. However, can I include these? Yes. So we give it what? Brackets. Now I need to unionize these two. I need to combine those domains. So what is my lowest number I can have now? 0. Do I get to include it? No. And it goes all the way to what? 2. Do I get to include it? Yes. So I show a bracket. So there would be the final domain. Now, did we do much math? Did we do much computational math? No, but what did we do? We did some thinking. All right? That's kind of what domain's all about. Functions. Anybody play baseball or tennis or golf? Let me take golf. Nobody plays baseball? You play baseball? You ever looked at your bat?
Sure.
What does it say on it?
Brand?
Okay, Easton or something like that, TPX, something like that.
Yeah.
But on the bat, it probably says composite somewhere on it. Okay? All the bats are tennis rackets nowadays, or even graphite shafts. They're really not all graphite. They're all composite. But what does a composite mean?
It's made of multiple parts.
Exactly. It's made up of multiple materials. All right? So a composite bat is not just a titanium bat. It's actually like titanium and steel alloy usually. All right? They put both of those things in to make it a mixture of something. That's what a composite is. So when we have a composite function, guess what we do? We take one function and put it in the other one. All right? It's the same kind of thing. All right? So if I have f of g of x, I'm substituting in g of x into my variable of f. All right? I'm making a composite. Okay? Just like a composite tennis racket, a composite bat, composite golf shaft, all those things. Actually, my driver has a composite too, if I think about it. All right, but anyway, they're made up of different materials. That's what it is. All right, so let's do this one. If I have f is x squared plus 2, or x plus 2, I mean, and then g is 4 minus x squared, and I need to do f of g of x. I like to write it in this notation. I'm substituting in g of x in for my variable of f. All right? So my g of x is equal to 4 minus x squared. And I'm substituting that into my variable into f. So now I end up having 4 minus x squared plus 2. And what should we probably do now? Combine like terms. I don't need to distribute a negative anywhere. All right, so I'm just combining like terms. So then I end up having negative x squared plus 6. And then I'm done. Let's look at this next one. If I have g of f of x, this is when I substitute in what? F in for the variable in g. All right, so now I'm taking this function and I'm substituting in the variable right there. So if I have g of f of, g of f of x, I end up having 4 minus the quantity of x plus 2 squared. Now what do I do with that squared quantity? I get to FOIL it, exactly. I get to FOIL it. However, make sure you use parentheses here, because I have 4 minus. Now, x plus 2 FOILed out. My first terms would be what? X squared. What do my middle terms become? 4x. Okay, you got a 2x and a 2x. That becomes 4x, and then plus 4. All right. What would I highly suggest you do right here? Distribute the negative. All right. I like to call it Star Fox. Choom, 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 choom. And you're totally allowed to do that during a quiz or a test. I'm totally cool with it. All right. I am. All right. So then let's combine like terms. So now I have g of f of x. Do I have any buddies to a negative x squared? Nope. Do I have any buddies to a negative 4x? Nope. Do I have any buddies for my constant? What happens to them? They cancel. I love it when that happens. All right. So now my g of f of x is equal to that. Now, let's look at this next part. I have g of f of negative 2. What do I do here? Ooh, easy there. I had breakfast. What do I do? Ooh, I substitute in negative 2 in for x. All right. So if I do g of f of negative 2, I substitute in negative 2 in for x right there. So now I end up having a negative quantity, negative 2 squared, minus 4 times negative 2. What is the quantity of negative 2 squared? 4, but then what do I get to do with it? Tack a negative on. So now I have a negative 4, and then plus 8, which is positive 4. All right. That is one way to Tampa, and I'm going to show you the other way to Tampa. If I'm already given, or I already made this already composite function, totally just substitute in. Everybody hearing that? However, if I don't, here's a better way to Tampa. If I do g of f of negative 2, I first do my inside out. All right, that's a movie. If I do f of negative 2 first, well, I substitute in negative 2 in for f. What do I get? 0. I get 0, right? And then I need to find g of 0. Well, I substitute in 0 in for my variable in g, and what do I get? I get 4. So g of f of negative 2 is equal to 4. Do you see how easy that was? Do I care which way you go to Tampa? I don't. All right, just get there. Don't break math rules. Get there. Kate's going to read for us.
Find the domain of f of g of x for functions given by blah 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 and blah blah blah.
Great job. Great job.
F minus G.
All right. No, it's f of g.
Oh.
All right. So
So
if I actually find my function,
multiplying them together.
I'm not multiplying. I'm making a composite.
Oh.
So if I'm actually finding f of g of x, I'm substituting in g into the variable in f. So I'm substituting this into the variable. So now I have square root 9 minus x squared minus 9. What happens when I square a square root? They cancel, right? So then I'm kind of left with 9 minus x squared minus 9. True? Well, what happens there?
Cancel one again.
Cancel the 9s. So then I'm left with negative x squared. Now, the domain of negative x squared. Do I have any domain issues with negative x squared? I don't have anything. However, we need to look at our composites. Okay, you truly didn't even have to find f of g of x, but we need to look to see if my parts of my composites are going to have any issues. Will this one have an issue? X squared minus 9. Will that one have an issue? No, it's well behaved. Well, polynomial well behaved. Will this one have any issues? Yes. Yeah. What we got to do with it?
Take the square root.
Not the square root thing. We set 9 minus x squared what? 9 minus x squared greater than or equal to 0. And so I'm going to add x squared, square root it, so it's going to be in between what? Negative 3 and 3. Do I get to include them? Yes, I sure do. All right, I sure do. So my domain is actually between negative 3 and 3. So you have to actually worry about the composite parts of your function. Does that make sense? Because negative x squared does not have any problems. Perfect. All right? Kind of like Jacob's mask. All right? Perfect. All right? However, we have to worry about the composites of them. All right? All right, write these out, and then we're going to do 49 and 52 together. On 49, I have f plus g of 3. So I have a combination. The way we deal with those combinations is we need to find f of 3 plus g of 3. All right? So I'm just looking at these graphs. Well, here's my f graph. Here's my g graph. So first I need to find f of 3. So what is f of 3? 2. So I end up with 2 plus, what is g of 3? 1. So 2 plus 1, most people call 3. See how we did that one? Let's do it again. Now I'm going to do f divided by g of 2. So this is just f of 2 divided by g of 2. All right? So we're doing our combinations right now. Well, I need to look at my f graph. What is f of 2? F of 2 is 0. Divided by, what is g of 2? 2. So I end up with 0. See how we do those combinations? Well, let's look at 52. Now we have what? Composites. Okay, now we have composites, and actually composites are very important in calculus. Okay, so if you're actually going that route, we do composite functions all the daggone time. All right, so we need to get used to these little. I like to think of them as little puzzles. All right, you just kind of go back and forth. All right, so let's do g of 1. So the first thing we need to do is we go inside out. All right, so g of 1. So what is g of 1? 3. So now we need to find f of 3. And so then we find f of 3, which is 2. So g of f, or f of g of 1 is equal to 2. See how that worked? All right, let's do the next one. So now I'm going to do g of f of 3. So I now need to do what first? I need to find f of 3. So what is f of 3? 2. So then I have g of 2. Well, what is g of 2? 2. So g of f of 3 is equal to 2. All right.